Hello there. Today's topic, comparing functions. Our essential questions: what are some ways we can compare different representations of functions, and how can we tell which function has a bigger rate of change? Let's get started with some vocabulary. First off, the word initial. Initial means the starting point or the output at the very beginning when the input is 0. We're also going to work a lot with rate of change. This is the speed that the dependent variable, or the output, the y-axis, changes compared to the independent variable, the input, or the x-axis. In a graph, we also call this the slope. Let's look at some different representations starting with graphs. Looking at this graph here, first we want to find the initial value. The initial value is the output at 0. In this case, the y-intercept is 10. Our rate of change, well, we could find our slope by looking at two separate points. I'm just going to go from here over to here, and if I count those steps, that's 10. This is 20 to 30, so that's 10. And then over is by 1, so that's 2. So if I do my rise over my run, or 10 over 2, that's going to give us our slope, 10 over 2, and we can simplify that to 5. Our output, when the input is 4, that's just asking what point does that go up to. So that's 4, and it looks like that's at 30. So our output when the input is 4 is 30. All right, try this second one on your own, and we'll go over it together. Okay, let's see how you did. First off, the initial value, that's our y-intercept at 0. Input 0 is 3. Our rate of change, we could find 2 points and then find our slope from there. I'm just going to start here. That's down 1 and over 1, 2, 3, 4. So that's 1 over 4 or 0.25. Go ahead and put that decimal in there too, even if you just wrote 1 over 4. Those are sometimes helpful when comparing rates. And our output with the input of 8, if we go over to 8 on the input, our output is this point right here at 5. So our output with input 8 is 5. Beautiful. Let's try working with tables. We're going to do this pretty much the same way, just looking at the inputs and outputs differently. Our initial value is going to be when the input, or the x, is 0, which gives us a y value of 8. So at 0, our output is 8. Our rate of change, we need to find the differences in our output. This would be like our rise. 8 to 16 is 8. 0 to 2 is a difference of 2. So if we did 8 over 2, that would give us our rate of change, which is 8 over 2, or simplify that to 4. You could have also picked different outputs. The difference between 8 and 28 is 20, and the difference between 0 and 5 is 5. And if you did 20 divided by 5, that would give you that same answer of 4. So it doesn't matter which differences you take, you just divide to find your rate of change. Finally, our output with the input of 2, x value of 2, our output will be 16. All right, see if you can figure out this table, and then we'll go over it together. Let's see how you did. So our initial value is actually going to be 3. That's at that 0, 3 right here. Our rate of change, if we find our difference between 3 and 12, that would be 9. Difference between 0 and 3 is 3. If we divide those, 9 divided by 3, that's going to give us a rate of change of 9 over 3, or 3. If you chose different values, you should have got the same rate of change. Our output with an input of 6 looks like it's 21. Moving on to our last representation that we're going to cover, equations. These are, right now anyway, in the form of y equals mx plus b. This makes it easy because our initial value is going to be when x is 0, or our y-intercept, like we learned with graphing lines, which is going to be 4. That's always just that b in the y equals mx plus b. Our rate of change is the same as our slope, which is next to our variable. Our coefficient for the x is 2. So that's our rate of change. And then our output, when the input is 3, That means we'd basically be putting in a 3 for the x. So that would be 2 times 3 plus 4. 2 times 3 is 6 plus 4, which gives us an output of 10. All right, you try this second equation, and then we'll take a look at it together. Okay, it looks like our initial value here is 12. That's our y equals mx plus b, the y-intercept. Our rate of change is the coefficient, the number next to our variable. In this case, it's 10. So our rate of change is 10. And our output, when the input is 2, that means we're going to switch this x out for 2. That's going to give us 10 times, instead of x, our input is 2. And then we add 12. 10 times 2 is 20 plus 12, which gives us 32. Flip that page over and let's try a couple example type problems. So here we've got 3 different functions. Function A is a graph, function B is a table, function C is an equation, and we want to find the initial value. So try to find the initial value of each function now. All right, looking at function A, that's our y-intercept at 0, 2, and 2 is our initial value. For function B, looking at our input of 0, has an output of 2.50 right there. And for our function, our y equals mx plus b, our y-intercept is b at 0, is going to give us a value of 1, an initial value of 1. There it is. All right, see if you could find the rate of change for each of these functions. Okay, looking at the graph, we're going to pick 2 points. It looks like they have points right there for us, and count down 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5, 6. Whoops. 6, so that's 5, 6. So our rise over run is going to be 5 over 6, and if we calculate that, it's going to be about 0.83. Looking at function B, our table, we want to find the difference between any of these output, these y values. I'll just pick these first two, and if we subtract 4.03 minus 2.50, we're going to get 1.53, and then the difference between those inputs, 0 and 2, is 2. So if we divide those, 1.53 divided by 2, that's going to give us 0.765. And if you picked any of these other differences, you should have got that same value. Lastly, our rate of change in our function is the mx in the y equals mx plus b. Our coefficient right here next to the x is 1.3. That's our rate of change. See if you could find the output at x equals 6 for each of these functions. Do that now. Okay, function A, when we go to the input of 6, our output value is 7. We have that point, 6, 7. Looking at our table, we can go to our input side to 6, and the y that goes with that is 7.09. And our function over here at y equals 1.3x plus 1, we need to put in the x value of 6, so that's going to be 1.3 times 6 plus 1, and if we multiply and add those out, you should have got 8.8. All right, now that we've got this table filled out, we found all our values. Try these out. You're going to put these in order of the initial values from least to greatest, also the rate of change from least to greatest, and with the output of 6 from least to greatest. Try that now. For our initial values, we got function C, which is 1, that's the smallest, then function A, then function B. For our rates of change, you should have got BAC, that's 0.765, 0.83, and 1.3 from least to greatest. And for the output at 6, you should have got ABC, just like the alphabet, 7, 7.09, then 8.8. All right, one more example. Looks like we have two car companies. It says the cost of renting a car from company A is described in the graph below. The cost of renting a car from company B is in the table to the right. First, see if you could fill this table out looking at initial costs, the rate of change or the cost per mile, and the cost if you drive 15 miles for each company. Do that now. So the initial cost of company A, it looks like it's going to be 30, our y-intercept right there. For company B, the initial cost, 0 goes with 40. Should have got 40 right there. And the cost per mile, or our rate of change. For the graph, we want to find our slope. I'm going to use this point right here, which goes down 5, since our scale is going by 5 on the y-axis. And then over by 5, 10, 15. Since our x-axis always goes by 5. That gives us 5 over 15, or about 0.33 repeating. Looking at our table for our rate of change, we want to do that same process. I'll just find the difference between these first two values. Difference between 40 and 41 is 1, 0 and 5 is 5. If we divide those, we'll get a rate of change of 1/5, or about 0.2 per mile. And that's the cost per mile in dollars, $0.2. And lastly, for a cost of 15 miles, if we look at our x-axis here, 15 matches with 35 for company A, and 15 matches with 43 for company B. Now that we found that information, take a second to answer these questions down here. Which company has the highest initial cost? Which has the highest cost per mile? And which is a better deal if you're planning to drive 15 miles? Try it out. All right, looking at the initial cost, it looks like company B with the cost of 40 is definitely higher. So that's company B. Which has the highest cost per mile? Here we've got company A with 0.33 cents or $0.33. And here we've got company B with $0.2 or 20 cents. So definitely it looks like company A has a higher cost per mile. And if we are going to drive 15 miles, which would be a better deal? One's $35, one's $43. Well, I would definitely go with company A, because $35 is going to be cheaper than 43. All right. Take a few minutes, write your summary answering those essential questions. I hope this video was helpful.